be a waste not to put them to their traditional use. So your 3-hour exam on constructor theory starts now. I'm sure you'll have no trouble answering questions. We're joined by a few of our highlight speakers from the last couple of days. I think we've got Alison online as well. We'll be coming to you for questions very shortly, but I thought we might start where we started yesterday morning, which was me declaring a spirit of optimism about where we're going with exploring the cosmos. And so I thought I'd just ask what, particularly after the last couple of days, you're feeling optimistic about. So why don't we start with you, Alexis? What excites you?
So first of all, thanks for inviting me. It's hard not to feel the excitement here, and I love this phrase that actually it's a race to find extraterrestrial life. And obviously, wearing kind of my AI hat on, it's like how can I help, right? So that was the thing. But for me, it made it a lot more real, and yeah, I got really a sense of excitement. And talking about it feels very close. That's the sense I got.
Excellent. Yeah, it's sort of optimism in the short term, which is the best kind of optimism. What about you, Arpita?
So I feel unending optimism when it comes to the scientific workforce. I think it is incredible, the range of ideas that comes out of this community. But I'll also say in my new role, I hear a lot of ideas. So it was really nice to hear even ideas I haven't heard of yet. And many of them are not in a pie-in-the-sky stage. They've actually been proven out in the lab. A liquid mirror was on the ISS. That's incredible. So we're not only dreaming about these things, we're actually making them happen, which is wonderful.
Yeah, I heard 3 sets of astronomers separately talking about what they're going to do with their 100-meter space telescope. So if we could just order a couple of those, that would be great. Let's come to you next, Alison. What are you optimistic about?
Well, firstly, I'm hoping that I'm not this huge thing on the screen, but I'm probably that cute, so let me just step aside.
I mean, it's almost more menacing if you're in the corner, so I think just embrace it.
I'm very hopeful about this pale blue dot here, simply because look at what happened with COVID. The horrendous deaths aside, we actually just continued at NVIDIA because we already had this webcam technology. This is like AI accelerated, and the compute behind the ability to have people virtual. I'm literally time traveling and have been this week. The reason I'm not here in person is because there are 3 separate conferences on at the moment. The IEEE is in Mountain View, covering space. The UN and the Outer Space Affairs Office have had their event in Vienna, and I've been basically, attending all of those. And it's that capability, that parallel, simultaneous capability that we have that is able to really, as I said in my talk, achieve, what we once thought was impossible. So I really do have a lot of hope for humanity. Yes, we hear a lot of bad stuff, but there's also a huge, much bigger, amount of good stuff that's happening out there, especially the innovation. And AI, for me, I live it daily, is nothing but exciting.
Excellent. Good stuff. And last but not least?
I suppose I'm most optimistic about the next frontier, right? So listening to all the talks, I can definitely put myself and imagine a world in which AI has met all our demands. We have found life somewhere, right? And we are at the next question of now what? And at that frontier, we get to redefine why we do our science and how we do our science. And I think that's the time where we can say, okay, it's not, we're not going to do it in the colonial sense anymore. We're going to include indigenous knowledge. We want to adopt an empathetic perspective here now that we've done all this discovery. So we are at the forefront of confronting those once we answer the type of questions that we discussed here. And that's very exciting.
Yeah, it sort of reminds me of something I think Suzanne Aiken said yesterday, which was that we have this nice story that we can tell politicians or funders or the broader world, which is we're looking for life in the universe, and then we get to do our complex science and find out about planetary atmospheres and the formation of the solar system and everything else. But it's almost like we need a broader, even broader story to fit the science that we want to do in.
Yeah.
One of the other themes that I think came out of a lot of the discussions, especially this morning, that I wanted to ask you about in particular, is that on one hand, there's this very strong sense that we want to build fast, we want to build many things, we want to diversify perhaps access to space and access to research and participation in research. But we also are in a world where scientific mega projects are taking over. You might argue that astronomy and allied sciences are following what particle physics has done in producing fewer and fewer, larger and larger experiments. And as we make use of these wonderful AI tools, the cost of entry gets bigger. So do you have any thought, do any of you have thoughts about how to balance those two things, the sort of mega project, ambitious, large-scale things that we know we need to do versus sort of the flexibility that you get from smaller, faster missions?
Yeah, I almost think those paths, even though I described them as two different curves, are not that separated. I think they start to weave together because these smaller projects start to de-risk parts of the mega projects, right? And suddenly, it isn't taking decades to build a segmented telescope with a coronagraph behind it. And so I think they're deeply complementary. I think some sources of funding are tied up in one or the other, but there's no reason we shouldn't talk to each other and make the technology speak to each other as well.
Yeah, and Alexis, when you were talking about particularly the Earth observation stuff that you were doing, it was struck how open that is. Like, there's a commitment, I think, on your side to be open and to do science in the open, even though it's coming from a commercial company, right? That must be very important.
So the motivation for a lot of this work is sustainability. So I always think about the question, we cannot work together on helping sustainability, we cannot work together on anything, right? So it's a very motivating space to be in, and actually, yeah, it's like collaborating with academic organizations, NGOs, and other private companies. So it's just much easier, and it's also, it's a great space to work in.
And are there lessons that people in other spaces, like as we think about building foundational models or big models for astronomy or for SETI or for data analysis in general, are there lessons about how to do that you can share with us, about how to be open?
Oh, how to be open.
Yeah. My point is it's not as... I think people sometimes think you can make something open by declaring it open, right? And that doesn't work for open source code or data. Like, you need to support a community around an open project.
Yes, absolutely. So basically, it's very important. So I have difficulty with kind of the general question. So what I can say is we want to work very closely with the community. So actually, the way we started in terms of the foundation model, also working backwards. So working with people who use Earth observation data and make sure whatever we build is immediately useful. So we've taken this kind of working backwards approach and being very open and working with experts in forestry, experts in agriculture. So they are basically with us from kind of day zero. And we had a goal from the beginning, anything we do will be made available, right? So,
Yeah.
But we also want to make sure we bring the kind of domain experts along with us, so then it's immediately useful. But also, there's a temptation in AI and machine learning to do the work in isolation and just add everything in there, right? But it also makes it, in my experience, this makes it very difficult to actually make progress. Because suddenly you have a million problems all at once. So actually, so working backwards with the people who really want to use this allows us to also prioritize, guide the work, and make kind of meaningful progress.
Reggie, you come from a different part of the ecosystem, a startup plus an academic affiliation. How do you think about sort of scale of projects and the needs that go along with that?
Yeah, what I've seen both in the academic setting and in the startup that has worked really well to scale that is getting a diversity of talent, right? And even in talking with people, in discussing with people throughout these 2 days, I'm just curious, how many of you identify as like artists? There we go. There's a couple, right?
Scattering, yeah.
Yeah. How many of you are like policy folks? There's a couple as well. So these are
I want to point out that one person put their hand up to both, so the Venn diagram does overlap, right? It's important
Right.
this is an opposite.
But there are, these people are part of the conversations already. Sometimes we may not be aware, but they are already in the room. So how do we elevate those voices? How do we recognize those voices? And I think startups do that very well because we're a small group and we get to know each other really well. And in some academic settings, that happens as well.
Yeah. I was going to actually, while we're talking about the audits, obviously it's a big part of Breakthrough Discuss that we've got early career people here as well. It's been great fun talking to the interns who are here from Berkeley and from Italy, as well as here in Oxford. So I wondered, is there advice to them, or what skills do you think we should be telling them to pick up for this world that we've described that is data-rich, machine-driven, fraught with possibility? Like, what should we be telling them? Raghu, do you want to start?
Yeah.
Please take notes, by the way, interns. This will be helpful.
Maybe. We'll see. My philosophy on this is learn the skill to the best of your ability, but don't lose your self-identity or humanity in it, right? And that includes your entire background, the holistic identity that you have. It'll always end up enriching the skill that you learn, and you'll learn more genuinely. If I've learned anything through all the struggles of PhDs and all that, it's that, find good mentors to hold your hand whenever you need, but don't let go of your absolute essence.
Alison, what about you? What would you advise people? Yeah, why not? Yeah. Very good.
Everything that's been said, I love that. But what our Peter said a minute ago about de-risking, AI is de-risking humanity, and we're learning so much more while we're on this path through AI. But definitely what we need more of than the computer scientists and the different, scientific field specialists are the artists, are the philosophers, are the, go read the late Dennett's, Daniel C. Dennett's book. It's amazing, really look deep into what we've just been told by David, really sort of get into that, proper meta side of things. But yeah, individuality and creativity is crucial in this field, and it's the one thing that puts us apart from augmented intelligence. It's that creativity side. We might have DALL-E and Gen AI, and we can sort of hold on to that and make money from that even. But we need the human creativity side. We say this a lot. It's a big part of the boot camp for Frontier Development Lab. Embrace imposter syndrome, because nobody knows everything. So everybody get together. It's conferences like this where you've got different scientific fields that are really crucial. So everybody's learning from each other, and they're not afraid to learn from each other at whatever academic level you are.
Thanks. No, good points. Arpita, what advice do you have?
So I'd actually say you don't need to do anything extra because you're already doing an incredible amount. So I think it's just so impressive, the number of skills we package into our academic journeys, and we just call them being an astronomer or being a physicist or a paleontologist. But if you kind of pick those threads apart, you're learning to be a science communicator, a mentor, a citizen, a good writer, a creative thinker, a practical thinker, right? And so, look at yourself in the mirror and appreciate what a well-rounded experience you're having in this journey. And when it comes time to get a job, be able to tell that story to someone else.
Yeah, the storytelling bit of it's important, I think. Alexis, what about you?
Yeah, I think it's a great question. So a couple of thoughts. I guess stay curious. Like, I think it's super important. Keep exploring. Talk to like diverse set of people. Like, this conference is great. So many interesting conversations I've had over the last couple of days. And I guess something one of my mentors told me a long time ago. Don't confuse basically training with education. So you can learn Python, you can learn TensorFlow, whatever, right? But always, keep focusing on education also, and learning how to think and having a scientific mindset. Those things are not going to go away. So, and don't underestimate them. Basically, those will be there for you forever.
Okay. Great. So now, armed with that advice, I think we'll turn to the audience. So we've got our cubes of power. There are questions all over the place. Let's start here, and then we'll go here, and then
I got it.
one there. Great. Okay, go.
Question for Alison.
Just hold it nearer your mouth. No, it should work. Yeah.
I missed that, I'm afraid.
I'll relay the question if needed. Yeah, go for it.
You'll have to relay.
Yeah, I'll relay it. That's fine.
Let's try this one.
Hang on, we'll swap mics out.
There we go. Question for you, especially on an NVIDIA perspective. GPU-based programming is well known for being highly energy intensive, especially in the data mining industries, and also slightly dubious in terms of mineral sourcing, especially for the chips. What's NVIDIA's perspective on this? As astronomers, we use GPUs, highly, especially in simulation and data processing, and we have more and more data from the square kilometre away, for example. How can NVIDIA guarantee that what we'll be doing is sustainable, and how can you provide the best course forward for us in terms of the environment?
Right. So sort of how can astronomers use?
I got that.
Okay.
I got it, Chris. I heard it. Thanks. Everything that we do at NVIDIA is about energy efficiency. We're driven because of the competitive nature of silicon to be the fastest, but we also have to deploy, and I didn't have time to sort of emphasize this in what I said earlier. We are deploying to billions, so at scale, and this is all manner of artificial intelligence. So we have to be the absolute efficient because we are deploying at scale. And if we don't, we don't make any money. It's as simple as that. So we're literally driven to be as sustainable and as efficient as possible. And I detailed how we're putting that into the actual hardware itself, as well as the augmentation we get from AI, providing even more additional efficiency. But what I'd like to see in the future is our technology on the moon, in space, helping with in situ resource utilization, getting to the asteroids, bringing back, minerals, doing dark, dirty industry on the moon and not on Earth any longer. These are all things that we can help with, and why I'm so impassioned by the space industry. So the reason I'm not there in person, I said, is because of the multiple amounts of conferences that are on now, but also because I didn't go back to normal after COVID. I remain virtual as much as possible, purely for sustainability. There is, nobody at NVIDIA more sustainable than I am. I work on the Earth 2 project, for example, which is, about sustainability.
Thank you. It's an important question, but let's take some others. So there's a guy with a mic just here. Yeah.
Hi, my question is to Arpita regarding risk tolerance and aversion in flight programs. The idea that we accept more risk and build cheaper and faster missions usually comes at the price of product and quality assurance. Faster, better, cheaper has been JPL's motto for the last 30 years, and we're starting to hit the wall, especially with the Simplex and CLIPS programs. For instance, on Simplex, Janus, the mission was canceled entirely. I have it from inside the Prime. They used to call it Janky Janus. Lunar Trailblazer survived a continuation termination review, but has been plagued with systemic issues due to underfunding of the Prime. If you consider CLIPS, for instance, the first in the CLIPS program didn't even make translunar injection, a valve failed in the propulsion system, 15 million pound instrument burnt up in the atmosphere. There's task orders, a review of all CLPS task orders that have pushed
I'm just
everything back.
checking there's a question coming at
Yes.
some point.
My question is, if we keep making craters on the moon rather than delivering science, we lose our credibility. How do we balance risk tolerance with credibility we need to maintain as scientists and engineers running flight programs?
Thanks. Yeah, good question.
Good question, hard question. So I'll say quality assurance is a goal, right? It's not a book, which is kind of what it is at the moment in most organizations. And so what it means to do quality reassurance or risk management is what we want to revisit, not the concept that there should be some guarantee of performance, right? I think even in a risk-averse environment, there is still risk, right? You never completely retire it. The question is, which kinds of risk are you tolerating? In terms of credibility, I think this is where parallel sources of funding are advantageous, because we don't have that burden to the public, for example, to show that their money has been spent well. This is where our founders have the power to say, I'm okay if some of these don't work. 1 out of 10 works, 2 out of 3 works. That's success for me. So we get to redefine success.
Yeah, I think as somebody who does a lot of public engagement, I think we can be braver in talking about risk as well. I think the public are smarter than we often give them credit for.
Yeah.
And I think people understand that we're doing difficult things. And I wish sometimes I think we talk about that more, because then when there is a failure, it can result in greater support for going again or trying again or doing something different. And I think we're a little too scared to fail because we feel that will turn off the political support. And I think we can have a more adult conversation. This is a really important discussion that I realize I'm now leading instead of chairing, so I'm going to stop and take another question.
Yeah, so can you hear me?
Yeah, if you hold it very close to your mouth in an awkward fashion. Yeah.
This is a question for our AI panelists. So usually in discussions of applications of AI into creative fields, be it science or the arts or so on, there is a fine transition of how far AI can push and when the human intervention is needed for the really creative aspects. So I was wondering if you can share an extreme example of machine creativity, not just intelligence, but creativity, be it as an emergent phenomenon or as a runaway process of an intended algorithm, which hadn't been expected and turned out to be super creative.
Okay, who wants to go first? Alison, go for it. You, of course, have access to an AI right now, presumably, so you can...
There is so much out there, and yet so little, and it's really, really frustrating. So little being done with the use of evolutionary algorithms. In my talk, I showed what we did with logistics, with the traveling salesman problem. And that's just one thing that's actually deployed and is out there in the world. This isn't theoretical stuff. This is actually out there. Domino's Pizza, as I said, use it for one of many. But look at, forgive me, I cannot pull the name from my brain at the moment, but Bristol University, Swarm Intelligence, there is a stunning amount of work being done there, which is discovering emergent technology in the robotics side, so AI with robotics. And that Swarm Intelligence then can pretty much translate, instantly, as is happening now, actually, because the CARDA team are in Mountain View as I speak, learning how to use Omniverse and Isaac. You can translate that into physical robots. Cadre is 3 robots that are going to the moon very shortly.
Yeah.
I don't think they'll have Swarm. I'm not quite sure, but that capability is out there. We're just waiting for it to be deployed.
Okay, so coming to an AI lab near you soon. Alexis, yeah.
Actually, yeah, great question. Just some time to think. I guess the things that come to mind are well, the kind of maybe not up-to-date example, like AlphaGo, right? The way it was playing, doing some moves that people thought, that's silly, right? Like no human expert did that. Why did he do that? And then people had to dig in and really understand. That was completely unexpected. And more recently, things like algorithmic design and chip design, right? Where things like deep reinforcement learning type algorithms are making an algorithm for you that's basically better than anything any human has designed. And that, for me, was unexpected. Like there was, Alpha Tensor, the bit Strauss's matrix multiplication algorithm that has been around for, 20 plus years, right?
Yeah,
so these are deeply impressive results.
Rigu, what about in your sensor world? Are there sort of creative approaches to data or to sensing that are being enabled by these technologies?
Yeah, but there is, right? It's telling us what parameters we're sensitive to and things like that. But I want to perhaps take a step back and look at the question a little bit differently in the sense of the AI informs me and then I inform the AI. We are one system together, and that's how it's going to work, right? That's always how it is. So I don't know if the AI is driving the innovation or I am driving the innovation. It's a feedback, and we're one system, right? And that's always how. There are specific instances where I've seen one revolution or the other, but if I take a step back, it's always feedbacks.
So I think we've got time for one more, so yeah, please.
Okay, thank you very much. I'm from the University of Johannesburg, and thank you to the panel for this very enlightening conversation. I think coming off of what you've said, and also Alexis's talk yesterday, and David Deutsch's talk, specifically when he mentioned that you can say the creators or you can say the producers of AI should think of, you can say the products that they create as their children, essentially, a product of their imagination. And as you've said, there should be a feedback loop where you're informing the AI is informing you back. But is there a possibility, and is this a concern, so we're going in the sci-fi zone, that the AI will stop, kind of interfere in this feedback loop and essentially become sentient and disobey?
Yeah,
and is this something that is an active area of research, or do we just think of it as something that will never happen?
Yeah, Alexis.
It is very much an active area where a lot of people. I would just draw the distinction about immediate risk and kind of longer-term existential risk, and I guess they're both being looked at very aggressively because, there's kind of alignment problem, right? And people are very much thinking about this. So, for example, these models already are quite powerful. So you want to make sure you avoid, for example, like producing a massive amounts of misinformation, having an agent like basically flooding, Facebook with individual like propaganda messages. So all these things are very real near-term risks. But people are also taking very seriously and thinking, and there's a lot of, I think, good work out there about the more kind of existential risk and what that means and how to overcome. It's just, I want, because all this existential discussion, I want to make sure people also recognize there are very immediate risks as well. And those are, need to be considered. Another example I thought about.
Can you give us an example? No, can you give us an example of a near-term risk that you're
Yeah, so I think the massive personalized misinformation is really now basically. People are actively, deep fakes and all these things are happening now, right? And there are concerted efforts to, very smart, identifying not just images that come from these models, so this kind of very gentle kind of watermarking that's very robust, but even language that's generated from these models. Basically, there are approaches now that it can, you can reliably detect it, especially if it's a longer passage of text. You can definitely detect that, and we are seeing that. People are employing these chatbots to review scientific papers, right? That's already happening.
Yeah, there was some amazing work from the University of Hull this week from astronomers looking at detecting deepfakes because the reflections of things in the eyes are not right. And they've adapted a computer vision technique developed for galaxy identification, which is fun. We are nearly out of time, but I want to ask you one quick-fire round of questions, one quick-fire question, which is that we're just starting, as you know, a 10-year engagement with Breakthrough Listen here at Oxford. And so I'm assuming that you'll all be back here in about 10 years' time. Pete's nodding, so I guess we're already on the hook, so that's good. So my question is, what will we be discussing at Breakthrough discussed in, let's say, 2033 that wasn't even mentioned in the last couple of days? It's a nice, easy question that I've given the panel absolutely no notice of. So let's go to the all-knowing giant floating head. Alison, do you understand?
I would say robotics. Obviously, we have, discussed this, but there is very little on the actual moon right now. But there's going to be a ton of robots and rovers and so much more information, and we'll have leaped forward in 10 years. Bear in mind what we were like 10 years ago.
Okay.
So
robotics, particularly on the moon. Who's next?
I don't know how unexpected it is, but I thought the point about basically exoplanets, I suspect with new signals coming, there will be a lot of excitement and this, but it will be but how do we validate, how do we verify?
Okay, validation, that's good. Arpita?
Yeah, so I'm an exoplanet astronomer, so I think we will be on the cusp of finding life, and the question will be, A, how do we reliably make that claim? And then how do we react to it, which I think is a multi-stakeholder conversation we have put off as a race and is upon us soon.
Okay, so contact protocols and validation and robots so far. Okay, what are you adding to the list?
I think I started mentioning this in the previous question as well, right? I hope it is that we confront we've achieved the pinnacle of the tech and all that, and we're starting to confront and really nurture and revolutionize the emotional aspect on how it meets those innovations.
Excellent, good stuff. All that remains for me to do is to thank clearly the Scientific Organizing Committee for Breakthrough 2033, but also our panelists for today for their talks and contributions. Thank you all very much. And to close the conference, or at least the formal parts of it, I'm going to hand over to our sponsor, Pete Wharton. Pete.
Thank you. Since you've sat through a two-day activity in the examination hall, I've heard from the instructors and proctors that you've all been granted first-class degrees. So first-class honors, I guess, is the right way. So I hope I'm not accused of grade inflation. But I really want to thank, first of all, the audience for a fabulous 2 days, and remind everybody there's a reception tonight. So have the really fun part. Although 7 p.m. Yes, 07 or 1900, right? I used to be in the military. I should get that right. Second, I'd like to thank all of our speakers and panelists. This has been, for me, very educational. And third, and probably this is most important, we've had a fabulous group of people here from Oxford, from Breakthrough Initiatives and so on, that have done all of the staff work for us. So I'd like to thank all of them with a round of applause. If they could stand up. Okay. Thank all of you. And with that, you're dismissed.